Good afternoon, everyone. Thanks for joining us for Quality Counts webinar discussing parking studies. My name is Roxy Booth. I work on QC's marketing team, and I will be your host today. On the right-hand side, you'll see a chat box. If you don't see it, you can click on the chat icon at the bottom of your screen. Please use this area as a parking lot to ask questions throughout the presentation. You can direct them specifically to me or have all attendees see the questions. At the end of the presentation, we will address any question that was asked. And today we're really excited to have a panel with extensive knowledge and experience doing a variety of parking studies. We have Mark Shields, who's our Director of Marketing, Rodriguez Jones, who's one of our Directors of Operations, and Robert Berryhill, who's our Operations Manager of the Carolinas. Thank you guys so much for taking the time to share about parking studies, how they work, and best practices. So I'm going to go ahead and kick it over to you, Mark, to get us started.
Thank you all again for attending today. For those of you not too familiar with Quality Counts, we are a transportation data collection firm with 10 offices across the US. We have over 200 employees and serve 41 states so far. We've also completed some projects abroad. We are proud to say that as of this year, we are 68% employee owned. Some of the folks that are full-time on our staff have a personal invested interest in Quality Counts and are very much ready to make sure your parking projects are a success. We also have 15 strategic partnerships, so where we don't have a particular capability to execute a data collection project, we do have partners that we can bring in to augment our capabilities to make sure that we are a one-stop shop for your data collection needs. We have over 400 years combined experience among our staff. We have serviced over 15,000 projects and over 900 clients. And since 2015, we've captured over 300,000 hours worth of video from turning movement counts to mainline automated video counts, et cetera. And in terms of fieldwork assets, we have quite a bit from camera systems to tube counters and Wi-Fi sensors to drones, which we'll talk about here in a few minutes. And again, where we don't have certain capabilities, we've brought in partners to augment what we are able to do to provide you with the best service possible. And now we'll pass things off to Rod to talk about parking studies.
Good afternoon, guys, and thanks for passing it over to me, Mark. My name is Rod Jones, and I'm the Director of Operations here at Quality Counts. I've been in the data collection industry for about 13 years now, and with Quality Counts for 5 years now. Today, we plan on talking to you guys about different types of parking studies that we're able to do. Our goal today is to show you some of the different tools that we have and some of the projects that we've done to pretty much stimulate your mind and help you think outside the box with some of the things that we're able to obtain with parking data. So I'll start off talking to you guys about our more traditional services, which we call it boots on the ground or on foot parking data collection. So with this method, we're using our proprietary cameras. We're using men or women on the ground, and then we're also using vehicles equipped with GPS devices. After that, I'll pass it over to Rob, and he'll talk to us a little more about some more in-depth curb data collection, and then we'll pass it on to Mark for him to finish us up talking about our most innovative way of collecting, which is the drones. So as I mentioned, with our most typical services, we're able to provide inventory, occupancy, make and model of vehicles, state tag information, registration stickers, parking restriction, and asset inventory. So as you can see with this list, inventory and occupancy, we found ways to semi-automate that process. But when it comes to the small things that are on the vehicle that can't be picked up by a camera, we're still sending people out in the field. But ultimately, as we go through this, you'll understand that we're picking what's the best tool for whatever type of study that we're doing. So we'll start with off-street parking, which is the most common. We often get projects where people want to know what's going on inside of garages or inside of areas that are not readily available to get an aerial view from. So with these cases, we're using our proprietary camera system. We're using people on the ground, and we're using video and our video reduction center to reduce that information down to data for you. So if we imagine a parking garage, we're essentially sending in people on the ground to do an inventory and occupancy of what is there and create a baseline at the beginning of the count. From there, we're putting cameras on the ins and outs of this location and pretty much counting how many cars are going in and out so that at any time throughout the day, we can create a baseline for you. We typically deliver these in 15-minute increments, but we can work with whatever time frame that you need. In addition, we do on-street parking. So this is any parking that's on the side of the road, which I ran into a lot in DC. That's a city that's just set up that way. So if you're in an area that has these type of studies, we're able to do those as well. With these, we're using more technology. We're using cellular devices. We're using vehicles that have GPS connected cameras. And even Garmin's to predetermine routes to make them the most efficient. Some cases we're even using bicycles. I'll talk about a project like that later, but ultimately the goal here is to collect inventory, occupancy, often turnover as well. And with this one, we're using a combination of driving those predetermined routes with a vehicle that's equipped with a GPS camera, so we can send those to our video reduction center and they can break it down just using that video on what was the inventory, what was the occupancy. With that, we're able to provide some heat maps, which I think Rob will talk about later. And we also provide this in Excel and PDF as well. So talking about on-street parking study, one of the ones I worked on is the Park DC project up in the Capitol. With this one, we collected the origin, state of the license plates, the vehicle type, the anybody that's illegally parked, visitor passes, and registration stickers. The goal of this project was to understand the way that people from outside of the neighborhoods are using designated parking spots that are in the neighborhood. So just to give a breakdown of this project, we were able to collect over 1,900 block faces and 100,000 vehicles in about 3 months' time using about 2 dozen staff. So we were having some staff members walk these predetermined routes in Georgetown, in Easton Market, in DuPont Circle, all of these high populated places. They walk a predetermined route and they collect information on the different vehicles. So these things that are listed on the left side. In addition, we had someone driving the routes with the GPS camera. So from there, we can get the inventory, the occupancy, and we also had these people equipped with handheld devices that connected to the DDOT database. So it populated everything in real time as we collected the information. This was definitely a big undertaking, but I was proud to say that we were able to get it done. Another kind of outside the box example that we had in DC was the Chinatown parking study. With this parking study, we were basically using bicycles to simulate vehicles looking for parking in the area. This helped get our client information on how long it takes a vehicle to find parking on a predetermined route. And also we had one person walking around to do an inventory and occupancy count at those predetermined routes to understand, are people double parking or are they parking normally? How many spaces are allowed on this block to see how it's being used. So we were able to accomplish this using some electric bicycles, 4 staff members, and then, like I said, we had one pedestrian that walked around and ultimately collected data that way as well. So with these couple slides, you can see, even though this is the base of the park and study collections with people being out in the field on the ground. We're still able to tackle some pretty large projects and think outside the box with the type of projects that we do. So next, I'll pass it over to Rob, who will talk to us more about park and curb space, which will be a more in-depth dive into our curbside data collection. Thank you.
Hello, everybody. My name is Robert Berryhill. I'll be talking about our semi-automated video approach, which provides high efficiency and ultimately verifiable accuracy. So when you compare the traditional on-foot clipboard method, you're forced to deal with clipboards, messy data transition, and also a larger study area will ultimately require more staff on site. And a person on foot can cover only really about a fourth of the area that a single driver is capable of. And really lastly, the data is not verifiable if you're just out there with, pen and pencil on a clipboard. How does our system work? Our vehicles are outfitted with front and side facing GPS dash cams, so we can focus on driving safely while the cameras do the on-site work for us. Additionally, a Garmin GPS device is preloaded with the study route to ensure proper collection. So really, we're just out there collecting the data and keeping our focus on the roadway. Next slide. So this is raw footage. It's being analyzed, and really, if we can see it, we can collect it and process it. So we just want to keep this in mind when we're scoping out projects. There's really a limit to what we're able to analyze as long as we're able to see it within view. Right. So how do we process our data? Well, after completing the field collection, we download the GPS embedded video from the cameras. Then we pull the GPS information into our system for processing. And lastly, we confirm each data point and manually add vital street information for a complete data set. So how does our system know what to use from the video? So any images containing GPS coordinates that fall within the study route are pulled into the database. So each captured segment of this route is logged into our system, along with any auto-generated license plate, permit, or sign information. Okay. So here's an example of a license plate report. The basic auto-populated information, such as the license plate number, along with the timestamp and location, can be observed. Next. So this information is then confirmed by a human processor for accuracy and manually paired with additional information such as the specific block face or the vehicle type. And really the complexity of these reports can vary greatly depending on how specific a project's needs are. So creativity can definitely play a factor here. So here's an example of a curb report, and similar to the license plate report, we have information that is auto-populated alongside the corresponding image. So the process of completing a curb space inventory is also similar. The data points are reviewed and confirmed by a human processor with additional street information manually added. So there's really 3 stages of quality control for these studies. Starting with the field check, we perform a practice run to confirm the feasibility of the study. This carries on with the in-field verification while collecting the actual data. Next is the video review stage, which will confirm that all segments have been covered with usable, clear footage. And lastly, during processing, we manually confirm all auto-populated information per data point by cross-checking against the corresponding image and study route map. So this technology centers around parking surveys, and curb space inventory with almost unlimited options for reporting each. And so curb space inventory can be delivered in multiple layers, including the actual report, along with the source database and KML files for reference. Vehicle occupancy can similarly be displayed with the addition of heat maps to convey the general availability and use of parking per block face, which is really useful. And the parking rotation deliverables take the data kind of a step further and break down the length of the occupancy for each stall throughout the duration of the study. And again, we can virtually zoom in on the data and provide a broader picture of what's going on, depending on what other specific details are paired with each data point. So estimating each project is definitely unique and requires an in-depth review. Along with the length in the study, along with the length in the study route of the proposed study, it is important to relay the specific type of data you're looking for when submitting a request. Again, the complexity can vary greatly depending on your specific needs. For example, are you needing a vehicle occupancy, or is it a full curb space inventory and parking rotation needed? So just kind of understanding the scope of your project and some of the basics beforehand really makes a difference. So projects we performed with this system, starting off with a parking rotation study for the city of Chapel Hill. We had a study route of 4 miles collected for this project on both a midweek and a Saturday. This project did have some parking garages that interfered with the GPS signal, so it did require some manual reduction. However, the majority of the project was completed using this automated system, and it worked great. Next, we have the 2019 City of Danville parking study, which involved multiple collection methods. The majority of the inventory portion was collected using the system, and several different parking classifications were broken out for this project and ultimately divided up and delivered by individual block face and or parking lot. So it was pretty complex study. From here, I'll hand it off to Mark.
Thank you. So now we'll turn our focus to using aerial collection methods for parking studies. Next slide. The first thing I always mention is that our pilots are Part 107 certified and are very familiar with all the restrictions that accompany that license. They're also familiar with the waiver process and low altitude authorization and notification capability procedures that are required by FAA to be granted clearance to circumvent some of those restrictions. So those restrictions include what you see on the right side of the screen here, such as no flying at night or outside the pilot's line of sight, don't fly over people, removing vehicles, etc. Next slide. There are 2 ways we typically collect parking data using drones. The first one I'll talk about is the creation of orthomosaic images, and the second is through the use of tethered or free-flying surveillance. Next slide. So we'll start talking about orthomosaics. Orthomosaic images are basically images stitched together from smaller high-definition images. So what we do is we use a flight planning software like Drone Deploy to set up the essentially set up a flight plan to tell the drone where to go and how often to take photos. And the drone will take off in a completely automated fashion. So it's not manually flying, it's a fully automated flight. Photos are generally taken about every 3 seconds as the drone traverses that flight path. And after those images are taken, they're uploaded to the cloud where they're stitched together into the final orthomosaic image. New software capabilities are constantly coming out now that allow us to look at things like pavement condition or build survey grade 3D models of the surveyed area after we collect those image sets. Next slide. The next method is through tethered or free flying surveillance. A tether is basically an extension cord that lets you fly and monitor an area of interest continuously with no need to land and swap out batteries. If you're free flying, as the name implies, without a tether, then you do have to land on occasion to swap out batteries. It's usually, most drones nowadays get about 30 minutes of flight time before they need to be changed out. So we may use this to continuously monitor an area. Again, there's automated softwares out there that can actually track and count vehicles as they're parked, or for general traffic studies as they make movements. Like if you're trying to do sort of like a turning movement count or an origin estimation study to accompany your parking study. Next slide. So a couple areas that we've used this, Montford study in Charlotte, or in South Charlotte, is one location where we use drones to collect some pretty in-depth parking data. We actually used a combined methodology for this project. We used drones to capture the majority of the inventory, but we supplemented that with on-foot counts, with just one person driving around to cover parking areas that were occluded by tree coverage. Because we did this pretty early in the years, around mid-year, so tree canopy did pose a little bit of a problem. So we generally get asked, how do you get around there being canopy and making sure that you're collecting inventory accurately underneath that canopy? And that's usually by supplementing a drone method with another methodology, like doing license plate studies or ALPR, or using on foot or on the ground personnel to capture that additional data. Next slide. This was a study in Raleigh, North Carolina that we captured a couple years ago. So because we're over a large downtown area, rather than using a drone, we actually used a fixed wing aircraft, but the flight principles, the imagery principles are the same. We were able to capture the entire downtown area using high definition cameras on the underbelly of a Cessna. And we took all those images, processed them through drone deploy, and we're able to create those same orthomosaics by stitching all those photos together into a final large image. So from that final large image, we were able to reduce all the data for all the individual surface lots in downtown Raleigh to get all the inventory and occupancy data for the study duration. And we ended up collecting about 10 hours of occupancy using the fixed wing aircraft. At the same time, again, there's kind of a need to use mixed methodologies here. We had a couple parking decks that also needed to be collected. So we used automated video counts to capture the ingress and egress of those parking decks so that we could get a baseline count of occupancy at the start of the survey period. And then we estimated occupancy by getting the ingress and egress of those deck driveways for the entire survey period, and use that to estimate the volume. Next slide. And the final one is NVCC, Northern Virginia Community College. We surveyed 5 separate campuses. Again, this was kind of a mixed methodology. We captured 60 hours per campus. It was 12 hours a day over 5 days. So we used drones to capture the majority of the inventory. For those areas that had parking decks, we had some folks at ground level capturing additional data. And the interesting thing about this one is we were able to get such high clarity and definition on those images that we were able to zoom in and see exactly what parking spots were occupied during certain times, so that we could determine what permit types were being utilized to park in certain spaces throughout the duration of that study. So not only were we able to do a full lot occupancy, but we could break the lot down into smaller segments after the fact, because we had those images to go back and support the data that we collected. So we had just a whole ton of images. We were able to break that down even more granularly for our client after the initial occupancy counts took place. And now we will move on to Q&A.
Awesome. Thanks, guys. We had a couple questions come through. First one is, what type of Garmin camera are you using? I didn't know it collected this level of GPS data.
Sure. So it's actually not recorded using a Garmin camera. So the Garmin unit is just simply for navigation and sticking with the pre-planned route. We can load those routes up into the Garmin unit. But the actual cameras that we use are it's called a VOFO dash cam. And we use that just because it is GPS capable and it has a wide view. So that's the actual cameras that we use. Hopefully that answers your question.
Okay, great. Thanks, Robert. And then regarding semi-automated curbside data collection, is there a time, oops, sorry, as they're coming in, I got lost my spot. Is there a time of day occupancy or duration of parking requested by your clients? Are there minimum runs required?
I've normally seen hourly intervals, and as far as the actual time span, I've seen, basically an hour at the lunch peak, um, the evening dinner peak, and then sometimes in the morning. But I've also seen um, like 8 hours straight, so it definitely can vary.
Okay, great. Thanks, Robert. And then, do you guys use image processing when you use the drone or just manual counting from the image?
We use manual counting. I mean, we haven't seen any software out there yet that can tabulate vehicles faster than we can just look at an image and count them by lot, because we also have to break those lots down into smaller sections typically. So you'll have the various lots within an overall orthomosaic, but then on occasion those broken down even further into permit type spaces, or having to separate out like ADA spots or something along those lines. And there's just not anything automated out there that I've seen that can that has that capability, that can do it faster than we can just run through it manually.
Okay, great. Thanks, Mark. And I have another question for you regarding the drone data collection. What is the permitting process that you had to follow? Can it be used in spotting unauthorized parking locations?
The permitting process. I mean, you could use a drone to find any. Can you repeat the question? I think I'm having kind of a hard time understanding this one.
Yeah. So, what's the permitting process you had to follow? And then, can it be used in spotting unauthorized parking locations?
The permitting process, I guess, for flying a drone, you have to have a Part 107, and then you also have to submit an FAA waiver if you're going to try to circumvent any regulations like flying over moving vehicles or basically any public areas. Some of the parking studies we've used with drones were kind of before these restrictions were heavily enforced and folks were a little bit more cavalier about it. So we'll kind of say that as an aside. We are much more strict about following those regulations now, and where we can't fly a drone because we aren't being granted a waiver, we typically fly fixed wing aircraft instead, because they can fly pretty much anywhere, even if you're near an airport. As far as finding people parking where they're not supposed to, I mean, definitely if you're using tethered surveillance, that's one method to do that. Otherwise, we could fly a mission every, say, 15 or 20 minutes to cover an entire area and see where people are parking where they shouldn't be. So that's definitely I guess a possible application.
Okay, thanks. And then can one of you guys please explain how the on-street counts are automated? Are people just watching the videos later and counting, or is there software involved?
It's assisted automation as far as I'm aware. Rob, you could probably speak to it better than I can.
Yeah, it's a semi-automated approach. So basically, there is a automatic aspect to it where it is taking the GPS information with the paired image, and it's auto-populating a map and a database, and it takes that work off our hands. We can simply just flip through the data points and just kind of focus on adding more data. The other aspect is the character recognition. So if there's a permit or a sign or a license plate, we can ultimately use the character recognition to add that into the auto population alongside the actual frame image.
Okay, great. And then I know, Rob, you said that some of the costs vary depending on what exactly the deliverables are, but can you give some of the cost ranges for a couple of the example studies that were presented today?
Sure. So the city of Danville was kind of a complicated one, utilizing multiple collection methods. So I don't know that I could easily speak on that one, but the city of Chapel Hill project, I believe it came to about $1,500, and that was basically 2 days and 3 hours for each day, and that was a 4-mile route for vehicle turnover.
Okay, great. Thanks for that example. And then can your counting process be used for spotting empty parking locations through app? Is there any ongoing advancement?
Could you repeat that question?
Yeah, it's kind of a tricky one. The wording's a little funky. It's can your counting process be used for spotting empty parking locations through app, maybe through an app? Is there any ongoing advancement? So maybe are there ways that technology is advancing where you could be able to spot empty parking lot locations through an app?
It's definitely a possibility, but I think as far as I'm aware, the solutions that do this would require fixed installations of like hardware either within the pavement or camera systems to be able to detect where there's not a vehicle occupying a spot, and then that would report it to an application that drivers could use to find where there's free parking spaces. It's definitely outside of our wheelhouse. Most of what we do is focused on temporary parking studies, just getting an idea of what the data looks like on kind of a snapshot basis versus something we would do continuously, like 24/7, to be able to provide that kind of information to drivers that are trying to find parking. So I hope that answers your question.
Okay, yeah, that's good. And then you mentioned O&D studies. How can we track where people are coming from and to for a local garage? Obviously, I mean the local road network only.
That's a good question. It really depends on how far out from the garage they're trying to go. We could use a tethered drone at a garage entrance to view where people are departing to, and we can track them for, I'd say, probably about a quarter to a half a mile down the roadway. It's kind of similar to doing like a weave study. We can use some automated methods to track those vehicles, or we can do it manually. It doesn't really matter which. It really just depends on how far you're trying to track them beyond the garage entrance. Because a drone can only fly so high, so we can only see those vehicles for so long before they're out of our field of view. So I mean, it's a possible application. We just haven't. That's a pretty unique one we haven't done yet.
Okay, great. And then does QC analyze the results of the parking study or just provide the data to the client? If QC does the analysis, how and with what methodologies?
We just provide the data results to the client. So it's typically in the form of just raw occupancy, inventory, and turnover data. And then the images and video to accompany that, just so that there's some inarguable proof supporting the data that we provided.
Okay, gotcha. And then can you obtain the average parking duration per vehicle?
Yeah, I mean, you can do that either with the LPR version where we pass it on an hourly or semi-hourly basis, or using drones where we could fly overhead every, say, 15, 20, or 30 minutes and see how long the same vehicle is occupying a particular spot.
Okay. And how do you deal with some commercial establishments allocate large areas of the parking lot to merchandise, display, and sales?
I don't know exactly how that would impact the data. I mean, if they're occupying spaces, I think we would probably take that out of inventory and report that as kind of a caveat to the data, where it's, you have X number of spaces of inventory, X level of occupancy for each hour, but with a little asterisk that states X number of these locations were actually occupied by something else. We've had similar issues with the lots, like portions of lots being closed down for like them cutting down. I had one at Baptist Hospital in Winston-Salem, North Carolina, where they were blocking off spaces to cut down trees. So we always have those sort of like unusual events happening. And there actually there were spaces taken up by vendors on campus as well during our parking study. So there's always stuff like that that's happening that we just report along with all the data that we provide. Like our field technicians and managers and stuff know that if there's anything unusual, that it has to get reported alongside the rest of the data. So we would make our clients aware. What they do with that information, I don't really know.
Right, that makes sense. Okay, that's all the questions we have here. If anyone wants to follow up on any questions they have or something comes to mind later, you can always email us at info@qualitycounts.net. Also, we plan to have a recording of this webinar up on our website and published via our social media channels by the end of the week. So if you have any colleagues or friends who might find it interesting, we will also send out an email with the recording for your reference. But I hope everyone has a wonderful and safe rest of your week. Thanks so much for joining us, and thanks, guys, for the info.